Welcome back, everybody. Today we're going over something called the trapezoidal rule. Last time we learned about left and right approximations. Remember here, if we did a left approximation, well, we'd have a rectangle that would be 0 high, so we'd have 0, plus a rectangle that, well, square, I guess, that's 1 high, so that's 1, 0 plus 1. If we were using a left approximation here, we would approximate the area to be about 1. But as we can tell, the area is more than 1. It's definitely more than 1. So we might say, hey, let's try the right approximation rule. Well, if we're doing right approximations, we've got a square right here, and so that'd be 1 here. Right approximation would be based off this one. That's 2. 1 plus 2 is 3. So we're either 1 if we're using the left approximation rule. We are 3 if we're using the right approximation rule. But if we really look at it, you've got 1, then don't those two pieces kind of make it 1? So isn't that more like 2? 1 plus half is really closer to 2. So really the answer is closer to 2. Well, how can we get right between the left and the right? And the trick is using trapezoids. Okay? So let's look at what a trapezoid is. A trapezoid isn't a rectangle. It's not a triangle. It's kind of a mix between the two. Usually one side is longer than the other. So what if we use that shape to approximate our image, our area under the curve, okay? That's gonna be much more accurate than using the left or right rules. Then here, that'd be our trapezoid. In this case, it's almost a triangle, all right? To find the area of the trapezoid is going to be the base times height 1 plus height 2 divided by 2, so the average height, okay? In this case, you have a height of 2, you have a height of 1. So this trapezoid right here, just this half, would be the base, which is 1, times height 1 is 1, plus height 2 is 2, divided by 2. 1 plus 2 is 3. 3 divided by 2 is 1.5. 1.5 times 1 is 1.5. Okay, so we've got 1.5. If we try the same thing over here, we have 1, which is the base, times height 1, which is 0, plus height 2, which is 1, divided by 2. 1 divided by 2 is 1/2. 1/2 times 1 is 1/2, 0.5. 0.5 plus 1.5 is 2. Hey, isn't that originally what we were guessing it was going to be closer to be? So that's our equation there. Sometimes you'll put a little summation symbol next to it, okay? And that's what we do when we are using the trapezoidal rule. All right, so I'm going to erase this real quick. Let's look at this problem over here. Let's say we want to find the area under the curve. To find the area under the curve, sometimes we'll use this symbol right here. From 0 to 6, 1, 2, 3, 4, 5, 6. So from 0 to 6, we want to find the area under the curve of this equation of f of x, where we have, do we want to split it into 6 intervals? Do we want to maybe just do 3 intervals? Let's just do 3 intervals with 3 intervals. Okay? So if there's 3 equally spaced intervals, where would I draw my lines? Where would I kind of cut everything off? Well, I'd probably do one here at the 6. So we need to make 3 spaces here. What's 6 divided by 3? It's 2. So each one is going to have a distance of 2. There we go. See, they're all equal. They don't always have to just be 1. It could be 2. So as we go through and do this, remember the equation is base times height 1 plus height 2 divided by 2. That's the area for a trapezoid. So area here, height 1 was right there. That's 0. So we've got 0 plus 3 divided by 2 times our base was 2. So we've got 2 times 0 plus 3 over 2. The next one, again, the base is 2. Height 1 is 3 plus 1 over 2 plus 2 times 1 plus 4 over 2. Okay, this is approximating roughly the area. Isn't this going to be a little bit more accurate than just using a left or a right approximation? Oh, heavens, yes. So here we go. this is going to equal 3 plus 4 plus 5. 3 plus 4 plus 5 is 12. So the approximate area under this curve, the entire area under that curve, is 12, using the trapezoidal rule. Now if we would have used the left or the right approximation rules that we've learned, it would have been either more or less than that. 12 is pretty dang close. Now if we would have broken this into 6 different segments instead, so 1, 2, 3, 4, 5, 6, would have been even closer to the actual value, okay? Alrighty, here's an example where the trapezoidal rule is really nice, okay? So we have this one small example here where it curves, it goes up all the way to 4, it goes from 0 to 4. Well, should it be worth 4 or should it be worth 0? If you're using the left or the right rule, it would either be worth 0 or it would be worth 4. But it's really worth somewhere closer to maybe 2. It's worth half that. So let's do a summation. Okay, we're going to sum. We're going to integrate. That's another way to say this. We're going to find the area under the curve from 0 to 6 of this function. All right, and let's do it 6 intervals. 6 equal intervals. So we've got 1, 2, 3, 4, 5, 6. There we go. And we want to find the area of each one of these. Okay? Well, here, on each of these, the base is just 1. So if you remember, the formula is base height 1 plus height 2 over 2 divided by 2, because it's the average of the two heights. That's really all that means. Find the average of these two heights. Average of 3 and 1 is just 2. Well, if you took that little triangle there and flopped it over, that's 2, okay? All right, so on each of these, the base is 1. So I'm not going to bother writing 1. And you know what, maybe I will just for you guys. Well, let's try this then. On this first piece, we have 1 times 3 plus 1 over 2 plus 1 times 1 plus 0 over 2 plus, now we're going to that third one, 1 times 0 and 2, so 0 plus 2 over 2 plus, now doing this one, we've got 2 and 1, 2 plus 1 over 2 plus 1 times, we're now doing this one, 1 and 0, 1 plus 0 over 2 plus, this last one, 0 and 4, 1 times 0 plus 4 over 2. Okay, now we can go through and solve. We've got 4 divided by 2 is 2, 1 divided by 2 is 1/2, plus 1 plus 1 and 1/2 plus 1/2 plus 2. We go through, we've got 2, 4, 5, 6, 7.5. Okay. So if we had to estimate roughly what is the area under this curve, we'd say 7.5. Ooh, you know what? But I made a mistake here. You can see what my mistake was? These are negatives. So see that third, fourth, and fifth one should be negative. See third, that should be a -2, -2, -1, -1. That'd make that -1, -1/2, -1/2. Here we go. Let's see how that changes that. We've got 1, 1, so that cancels those out. We're left with 1.5. So remember, this is a negative area. This is below the x-axis, so this is a negative area. These are positive areas. So what we do is we subtract this from what the positive areas are. Alrighty, I want you to try this one on your own. I want you to integrate or find the area under the curve from 0 to 4 using 2 intervals. 2 equally divided intervals. Okay. Alright, pause the video if you need to. I'm about ready to give it a try. Okay, you should pause the video. Here we go. So if we're going to split this into 2 intervals, well, that's one side of it. How would we split this in half? Is this a good representation of half? Way over here? No. How about over there? No. Right there in the middle would be half. Okay. So I'm drawing my intervals. Basically got a triangle, and I've got this shape right here, okay? Something like that. I'm trying to figure out the area under the curves. So what I do here on this first part is I look at the base, which is 2 times my two heights. My heights are 0 and -1 divided by 2. Plus my next trapezoid, I've got a height of 2 times -1 plus 3 over 2. Now, do you think the area is going to be positive or negative? We're about ready to find out. Here we've got the 2 and the 2, they cancel. So that leaves me with -1. Here the 2 and the 2 cancel. -1 plus 3 is 2. What's -1 plus 2? It's +1. That is the answer to this equation. Okay. It's roughly 1 is the total area under the curve. Let's try another one. Alrighty, here we go. This one is your time to shine. We want to integrate from 0 to 3 using 3 equally spaced intervals. What would the answer be? Okay, you should have the answer now. If you don't, pause the video and give it a try, okay? This isn't hard math. I know you can do this, all right? I know you can do this. So here we go. We look at the first interval, second interval, third interval. We've got 1, 2, 3 intervals, all right? Here on this first one, the width is 1. So we've got 1 times, let's see here, -1 plus 1 over 2 plus 2, sorry, that should just be a 1. 1, we've got 1 plus 2 over 2 plus 1 times 2 plus 0 over 2. Go through, solve. -1 plus 1, isn't that just 0? So that's 0. If you think about it logically, isn't this area the same as that area? So shouldn't it cancel each other out? Just one way to think about it. 3 divided by 2 is 1.5. Finally, 2 times 1 is 2, 2 plus 0 is 2, 2 divided by 2 is 1, 1 times 1 is 1. We're left with a total area under the curve of roughly 2.5. Now again, is this exact? No, this isn't exact. We're trying to get as close as we can to the actual answer. If you looked at the trapezoid there and the trapezoid there, they're close. We can't say that they're exact though. So we're really trying the best we can to get the best answers possible. If you got 2.5, way to go. That is awesome. I'll do one more for those of you that feel like, hey, you know what? I want one more example. If you feel like you got it, cool. Jump off, try the assignment. All right, here's the last one that I promised you. I want you to integrate from 0 to 8 using 4 separate intervals with the trapezoidal rule, okay? It looks like there's 8 here. Split it up, tell me what you get. All right, pause the video if you don't have the answer already. I'm about ready to give you the answer. Okay, here's the answer for those of you that need it. So we need to split it into 4 intervals. So we've got 8 over here. So let's see here, we split it, we split it, we split it. Okay, so I did it in half, then I split each of those halves in half. That gave me 4 intervals. They're all 2 wide. So here, if I'm using the trapezoidal rule, do I worry about that dot? No, I don't. Okay, I use the beginning and the ending. So that would give me a width of 2 times 1 plus 1 over 2. Plus, this has a width of 2 times 1 plus, ooh, I'm sorry, those should be -1s, shouldn't they? I almost got it wrong. -1, +1 over 2. Plus, see here, we've got +1, plus +1, +3. All right, well here, the -1 and the 1, they cancel each other out. That's gone. Here, we've got the 2's cancel, the 2's cancel, the 2's cancel. That's a nice thing when it's an interval of 2. 2 times something over 2, the 2's just cancel each other out. Makes it a whole lot easier. So we're left with -2, +2, and +4. -2 and +2 cancel each other out. So the total area under this curve is somewhere around 4. Again, that's an estimation. We're trying to approximate, we're trying to figure out what is it roughly. We don't know. We really don't know. But this is as good of a guess as we're gonna get, unless you split it up into even more intervals, which you could, which we're not going to do. But you might have to on your homework today. Ha! Anyway, all right, the time is yours. If you have more questions, let me know. I can help you with a couple more example problems. Other than that, good luck.